In this video we're going to look at summing up infinite geometric series. So I'm going to do a few examples. I'm going to start with one here and then I'll put on some more as we go. So the sum for an infinite geometric series is s equals the first term over 1 minus the common ratio, as long as that common ratio is in between -1 and 1. So that's what we need to determine. So my first one here, I have what's called an alternating series, because every time n goes up by 1 it's going to switch back and forth between positive and negative. Now that doesn't keep us from being able to find the sum. It is infinite as long as our common ratio is less than 1, the absolute value of it. By properties of exponents, since these are both to the n, I can write this as -2 over 8 to the n, or -1/4 to the n. The absolute value of that is in between -1 and 1. So our formula applies, and what we have to do is take the first term, and that's important. Make sure you actually calculate the first term. Because I have n equals 1 for my first term, when I put in 1 here, I'll -1/4 to the first, which is -1/4. So that will be my first term, over 1 minus the common ratio, so -1/4. I solve this and I've got it. So -1/4 over, those will both go to positive, so that's going to be over 5/4 equals -1/4 times 4/5. Sorry, we're going to flip and multiply. And so that gives us a -1/5. So that's our sum there. Let's take a look at another one. What if we had our sum from n equals 2 to infinity of 2 to the n over 4? Well, in this, our common ratio is actually 2, so this is not going to converge. This will definitely diverge. We would need the 4 to be the n in order for this excuse me, to converge. Now we can do this one, and we got the summation of n equals 2 to infinity. By property of exponents, we get 2 over 4, or 1/2 to the n. My first term is going to be when n is 2, so that's actually 1/4, because 1/2 squared, over 1 minus 1/2, which equals 1/4 times, that's 1/2, flip and multiply, 2 over 1 equals 2 over 4, or 1/2. So there's a couple examples of doing geometric series. I'm going to have another video where we do a few more examples, but I didn't want this one to be too long.